The life of a star is a journey marked by incredible transformations, from its fiery birth in a stellar nursery to its final, often dramatic end. Stars are the fundamental building blocks of galaxies, including our own Milky Way, and they play a crucial role in the universe by creating the elements that make up everything we see around us, including life itself. The story of a star begins with the slow accumulation of gas and dust, and over millions to billions of years, it evolves through distinct stages, each governed by the complex interplay of gravity, pressure, and nuclear fusion. A star's life begins in a vast cloud of gas and dust, known as a molecular cloud or stellar nursery. These clouds are cold and dense, often extending over several light years. Within these clouds, small regions may become gravitationally unstable, causing the gas and dust to start collapsing under their own gravity. As the material collapses, it heats up, forming a dense core called a protostar. This is the star's earliest stage, where the material continues to fall inward, feeding the growing mass of the protostar and raising its temperature. Once the core reaches a critical temperature, nuclear fusion ignites, and the protostar becomes a main sequence star, the longest stage of a star's life. During the main sequence, a star is in a stable state, where the inward pull of gravity is balanced by the outward pressure created by nuclear fusion. In this process, hydrogen atoms fuse to form helium, releasing enormous amounts of energy in the form of light and heat. This energy radiates out from the star's core, giving the star its characteristic brightness. The length of time a star spends in the main sequence phase depends on its mass. More massive stars burn through their fuel much faster than smaller ones, shining brighter and hotter, but living shorter lives. For example, a star like our Sun has a main sequence lifespan of about 10 billion years, while much more massive stars may only last a few million years. As a star exhausts the hydrogen in its core, it begins to evolve into the next stage of its life. For stars like the Sun, this transition marks the beginning of the red giant phase. With no more hydrogen to fuse, the core contracts and heats up, while the outer layers expand and cool, giving the star a reddish hue. In this phase, the star may begin fusing helium into heavier elements like carbon and oxygen. The red giant phase is relatively short compared to the main sequence, and it represents a period of instability as the star struggles to maintain equilibrium. Eventually, the outer layers of the red giant are shed, creating a beautiful shell of gas known as a planetary nebula, while the core remains as a dense, hot remnant called a white dwarf. The white dwarf will gradually cool and fade over billions of years, ultimately becoming a cold, dark object known as a black dwarf, though the universe is not yet old enough for any black dwarfs to exist. For more massive stars, the end of life is even more dramatic. These stars go through a supergiant phase, where they fuse heavier elements in their cores, building up layers like an onion. When the core's fusion process reaches iron, it can no longer produce energy to counterbalance gravity. The core collapses rapidly, triggering a supernova explosion, one of the most energetic events in the universe. This explosion disperses the elements created during the star's life into space, enriching the interstellar medium and seeding future generations of stars and planets. The remnants of the core can become either a neutron star or, if the star was sufficiently massive, a black hole. Neutron stars are incredibly dense objects, where the core has collapsed to the point that protons and electrons have merged to form neutrons. Black holes, on the other hand, are regions of space where gravity is so strong that not even light can escape. The life cycle of a star is a key driver of cosmic evolution. Through the process of nuclear fusion, stars produce the elements that make up planets, moons, and ultimately life itself. The carbon in our bodies, the oxygen we breathe, the calcium in our bones, all of these elements were forged in the heart of a star. When stars die, they return these elements to space, where they can become part of new stars, planets, and even living organisms. In this way, the life of a star is intimately connected with the broader processes that shape the universe. Understanding the life of a star also provides insights into the fate of our own sun and the future of the solar system. As the sun ages and eventually becomes a red giant, it will expand to engulf the inner planets, possibly including Earth. While this event is billions of years away, it underscores the transient nature of stars and the delicate balance that sustains life in the universe. In conclusion, the life of a star is a testament to the dynamic and ever-changing nature of the cosmos. From its birth in a cloud of gas and dust to its final moments as a white dwarf, neutron star, or black hole, a star's life is a journey of transformation and creation. Through their lives and deaths, stars have shaped the universe as we know it, leaving behind a legacy that continues to influence the formation of new stars, planets, and the very building blocks of life.